So, welcome on the lecture series on mathematical methods and its applications. So, we were seeing Fourier series and what are various properties of Fourier series that we have discussed in the last lectures. Now, this is Parseval's identity. Now, what Parseval identity is and how it is important to solve few problems on Fourier series, let us see. Now, it states that the Parseval identity is given by integral minus L to plus L fx whole square dx is given by L times a naught square by 2 plus summation a n square plus b n square, provided Fourier series of fx converges uniformly in minus L to L. Now, what is the proof of this identity? Now, what is the Fourier series expansion of fx? We know that Fourier series expansion of fx is nothing but it is a naught upon 2 plus summation n varying from 1 to infinity a n cos n pi x upon L plus summation n varying from 1 to infinity b n sine n pi x upon L. So, this is how we can expand a function into terms of sine and cosine terms. Now, we want to find out in minus L to L integral minus L to L fx whole square dx. So, you simply multiply both sides by fx and integrate from minus L to plus L. So, what we will get? Integral minus L to L fx whole square dx from this side, it is nothing but a naught upon 2 integral minus L to plus L fx dx plus summation n varying from 1 to infinity a n, because x is only here. So, it is integral minus L to plus L fx cos n pi x upon L into dx, this term, plus summation n varying from 1 to infinity b n and integral from minus L to plus L fx sine n pi x upon L into dx. Okay. Now, if you recall the formulas of a naught, a n and b n. Now, what is a naught? We already know that a naught is nothing but 1 upon L integral minus L to plus L fx dx. A n is nothing but 1 upon L integral minus L to plus L fx cos n pi x upon L into dx, and b n is nothing but 1 upon L integral minus L to plus L fx sine n pi x upon L into dx. This we already know. So, what this value is? Integral minus L to plus L fx dx. This is nothing but a naught into L. Okay. So, this value is nothing but a naught into L plus summation n from 1 to infinity a n. Now, this value integral minus L to plus L fx cos n pi x by L dx is nothing but a naught a n into L. So, this is nothing but L into a n plus summation n varying from 1 to infinity. Similarly, this value is nothing but from here this value is nothing but b n into L. So, this is nothing but L into b n. So, hence this expression will be nothing but L into a naught square by 2 plus L into summation a n square n varying from 1 to infinity plus L times summation n from 1 to infinity b n square. So, this can be rewritten as L we can take common a naught square upon 2 plus summation n varying from 1 to infinity a n square plus b n square. So, this identity is called Parseval's identity. Okay. Now, so if we have half range series which we have discussed in the last lecture, half range Fourier sine or cosine series. Okay. Half range cosine series of the function fx in the interval 0 to L. So, that can also be using Parseval formula, that can also be derived basically. What was Fourier cosine series? If we have a half range, so and we want a even extension of the function even periodic function, that is in the terms of cosine series, cosine terms. So, what is the expansion of that function? It is nothing but f(x) equals to a naught by 2 plus summation n varying from 1 to infinity a n cos n pi x by L. This is how we can write down a function f(x) in terms of cos. Okay, we take a even extension of the function. So, what are a naught? What is a naught here? A naught is nothing upon 2 upon L integral 0 to L f(x) dx. And what is a n? A n is again 2 upon L integral 0 to L f(x) cos n pi x upon L into dx. So, again we multiply both sides by f(x), integrate from minus L to plus L. So, what we will obtain? Integral minus L to L f(x) dx, f(x) whole square dx is nothing but a naught upon 2 integral minus L to L f(x) dx plus summation n from 1 to infinity a n integral minus L to plus L f(x) cos n pi x upon L into dx. Now, this is a naught upon 2. Now, this value, okay, it is from 0 to L, yeah, it is from 0 to L, it is not from minus L to plus L, because it is a half range, okay, it is a half range. So, it is from 0 to L, okay, so integrate from 0 to L. Now, 0 to L, this integral is nothing but a naught L upon 2. So, it is a naught L upon 2 plus summation n from 1 to infinity, it is a n, it is again L into a n upon 2. So, this is nothing but you can take L by 2 common, and it is nothing but a naught square upon 2, okay, plus summation n from 1 to infinity a n square. So, which is the same expression L by 2 a naught square by 2 plus summation a n square n from 1 to infinity. So, this is how the Parseval identity can be used when we have a half range cosine series. Similarly, if we have a Fourier, if we have a half range sine series, that is we extend the function considering function as an odd function, okay, then the Fourier's expansion is given by f(x) equals summation b n sin n pi x by L, and using Parseval identity or the formula we will obtain 0 to L f(x) whole square dx will be nothing but L by 2 summation b n square. So, that can also be derived using the same lines, this formula can also be derived, okay. Now, next is root mean square value. The root mean square value of the function f(x) in the interval a comma b is given by, it is under root of integral a to b f(x) whole square dx divided by b minus a, under root of the entire expression. It is also known as the effective value of the function, and it has application in the theory of mechanical vibrations and in electrical circuits theory, okay, this root mean square value. Now, let us solve few problems based on Parseval identity. Now, apply Parseval identity to the function this, okay, and deduce that this equal to this, okay. So, this series we have to find out using Parseval identity. So, now f(x) equal to x is an odd function, okay, f(x) equal to x from minus pi to plus pi is an odd function. It will contain only sine terms, sine series, okay, a naught and a n are 0. So, the f(x) which is equal to x will be nothing but summation n from 1 to infinity b n sin n x, because L is pi, okay. So, what will be b n? B n will be given by 2 upon pi integral 0 to pi x sin n x dx, okay, f(x) sin n pi x by L into dx. Now, you integrate this, it is 2 upon pi, first as it is integration of second, which is minus cos n x upon n minus derivative of first into integration of second and 0 to pi. So, applying integration by parts we obtain this. Now, take the limits, it is 2 upon pi, negative will come outside, Okay, it is 0 when x is pi or 0, and when x is pi, it is nothing but pi into minus 1 ki power n upon n, and when x is 0, it is 0. So, it is nothing but 2 into minus 1 ki power n plus 1 upon n. So, this will be Bn. Okay. Now, what is Parseval's identity? It is integration from minus pi to plus pi fx whole square dx will be equal to L times, L is pi here, pi times a naught square upon 2 plus summation a n square plus b n square. So, this is basically Parseval's identity. So, this is equal to, now this implies minus pi to plus pi, this is x dx, which is equal to, okay, x square, because f x is x, and pi a naught is 0, a n is 0, only b n is there, and b n value is this. When you square this, it is summation n from 1 to infinity, it is 4 upon n square when you take b n square. Okay. So, this implies, now it is an even function, it is nothing but 2 times 0 to pi x square dx, which is equal to pi into 4 will come out, summation 1 by n square, n from 1 to infinity. So, this further implies 2 times x cube by 3 from 0 to pi, and it is 4 pi, it is 1 by 1 square plus 1 by 2 square plus 1 by 3 square and so on. So, this implies 2 upon 3 pi cube is equal to 4 pi into this expression. So, therefore, this value is nothing but, when you simplify this, so this is nothing but pi square by 6. When you simplify this, so this expression is nothing but pi square by 6. So, hence using Parseval as a Parseval identity, we can easily find out the value of this series. Okay. Now, the next problem. Now, the next problem is f x equal to x square, it is an even function. Okay. And when we apply Parseval identity for this problem, it is an even function, that means it will contain only cosine terms. So, Bn will be 0. Okay. So, what will be function f x? F x is x square. So, first let us compute a naught. A naught will be nothing but 2 upon pi integral 0 to pi f x dx, which is nothing but 2 upon pi integral 0 to pi x square dx, which is equals to 2 upon pi, integration is x cube by 3 from 0 to pi. So, it is 2 upon 3 pi into pi cube, which is 2 pi square upon 3. So, this is a naught. Okay. Now, a n is 2 upon pi integral 0 to pi f x cos n x dx. Okay. Now, you integrate by parts, it is 2 upon pi, it is x square sine n x upon n minus 2x minus cos n x upon n square minus minus plus 2 into minus sine n x upon n cube from 0 to pi. Now, sine terms will be 0 when x is 0 or x is pi. So, only this term is remaining, and it is also 0 when x is 0. So, it is nothing but 2 upon pi, 2 this will also come out, and it is nothing but pi into minus 1 ki power n upon n square. So, this is nothing but 4 into minus 1 ki power n upon n square. So, this will be a n. So, we can easily find out the Fourier series of this f x. which is nothing but, we already know it is nothing but x square is nothing but a naught upon 2, that is pi square upon 3 plus summation n from 1 to infinity, a n is this value which is 4 minus 1 ki power n upon n square into cos n x. So, this will be a Fourier series of this function x square. Now, if we apply Parseval identity for this problem, so what will be that? It will be minus pi to pi f x whole square dx will be equals to L times a naught square upon 2 plus summation a n square plus b n square, and varying from 1 to infinity. Now, this b n is 0 because it is an even function. Okay. So, this is nothing but minus pi to plus pi x ki power 4 dx, and it is pi times a naught square upon 2. A naught square is 4 pi ki power 4 upon 9 into 2 plus a n square. A n square is 16 upon n ki power 4, n is varying from 1 to infinity. Okay. Now, when you simplify this, what we will get? So, now using Parseval identity in this expression, we obtain this. Now, if we simplify this, this is an even function. So, it is 2 times x to the power 5 upon 5 from 0 to pi, which is equal to, it is 2 pi ki power 5 upon 9, okay, plus 16 pi into summation 1 by n ki power 4. Okay. Now, this is nothing but 2 upon 5 pi ki power 5 minus 2 upon 9 pi ki power 5, which is equals to 16 pi into summation 1 by n ki power 4. So, this implies it is 2 upon 2 this common. So, it is nothing but 4 upon 45, which is equals to 16 pi into summation 1 by n ki power 4. So, this implies it is nothing but pi ki power 4 upon 90 will be equals to summation 1 by n ki power 4. So, hence we have proved this, that summation 1 by n ki power 4 is nothing but pi ki power 4 upon 90. Okay. So, this is how we can apply Parseval as identity in this problem to solve this equation. Now, let us try one more problem which is neither even nor odd, it is x plus x square, and we have to apply Parseval identity to find out the value of this expression. So, again we can apply Parseval identity in this problem, let us see. So, what will be fx? What is fx? Fx is x plus x square. So, it will contain all terms, sine terms, cosine terms, it will contain all the terms. So, we have to find a naught, a n and b n. So, what will be a naught? A naught will be nothing but 1 upon pi integral minus pi to plus pi x plus x square dx. So, this x is an odd function, so this will be integral will be 0, only this will be left. So, it is 2 upon pi integral 0 to pi x square dx. So, this is nothing but x square dx, okay, x square dx. So, it is nothing but 2 upon pi, it is x cube upon 3 0 to pi, which is equals to 2 upon 3 pi into pi cube, which is 2 pi square upon 3. So, this is a naught. Okay. Now, what will be a n? A n is 1 upon pi integral minus pi to pi x plus x square cos n x dx. Now, x into cos n x is an odd function. With respect to x, it is 0, and x square into cos n x is an even function. So, it will be 2 times pi from 0 to pi, it is x square cos n x. Again, we will apply integration by parts to solve this. It is 2 upon pi x square integration of this, which is sine n x upon n, minus derivative of this integration of this plus 2 integration of this from 0 to pi. So, only one term will left, which is nothing but 4 upon pi n square, and it is nothing but when x is pi, so it is pi times minus 1 ki power n. It is 4 upon pi and pi cancels out, it is 4 n square into minus 1 ki power n. Okay. So, this will be a n. Now, let us compute b n. b n is nothing but 1 upon pi integral minus pi to plus pi x sine n x dx, x plus x square, sorry, it is f x is x plus x square. So, it is x plus x square. Now, x into sine n x is an even function and x square sine n x is an odd function. So, x square sine n x will be 0, it will be 2 upon pi integral 0 to pi x sine n x. So, again we will apply integration by parts here. So, it is nothing but 2 upon pi x into minus cos n x upon n minus derivative of first integration of second minus sine n x upon n square, and it is from 0 to pi. So, it is nothing but 2 upon pi, minus will come out, n will come out, and it is nothing but pi times minus 1 ki power n. So, pi cancel out, it is nothing but 2 upon n minus 1 ki power n plus 1. Okay. So, this expression will be here. So, we got the values of a naught, a n and b n. We can directly apply Parseval identity to find out the value of this expression. So, what is Parseval identity now? So, let us note down the values of a naught. A naught we obtain 2 pi upon square upon 3, a n we obtain as 4 upon n square minus 1 ki power n, and b n we obtain as 2 upon n minus 1 ki power n plus 1. So, these values we have obtained. Now, we can apply Parseval as identity. So, this is integral minus L to plus L f x square whole square dx, which is equals to L into a naught square upon 2, that is 4 pi ki power 4 upon 9 into 2 plus summation a n square, that is 16 upon n ki power 4 plus b n square 4 upon n square. So, this implies, so first we simplify this. Okay. So, this integral is nothing but minus pi to pi, it is x square plus x ki power 4 plus 2 x cube whole into dx plus it is, which is equal to, it is 2 pi ki power 5 upon 9 plus 4 pi and summation 4 upon n ki power 4 plus 1 by n square. So, this is the required expression which you want to find out. Okay, the required expression. So, we can easily simplify now, it is an even function and odd function. So, this will be 0 and it is 2 times, it is x cube upon 3 plus ki power 5 upon 5 from 0 to pi, and it is equals to 2 pi ki power 5 plus upon 9 plus 4 pi into summation 4 upon n ki power 4 plus 1 by n square. So, this implies 2 into, it is pi cube by 3 plus pi ki power 5 by 5 minus 2 pi ki power 5 upon 9 and whole divided by 1 upon 4 pi, I mean 4 pi is equal to summation 4 upon n square plus 1 upon and 4 plus 1 upon n square. So, we can simplify this value. On simplify we will get the value of this expression. So, this is how one can apply a Parseval identity to find out the value of some series expansion using Fourier transforms, using Fourier series. Okay, sorry. So, thank you very much.